time for a video. I want to bring it back to some global heating issues. I know we've been going on about the war in Iran a lot recently. There are considerable, significant overlaps between topics I usually cover, like global atmospheric physics and global heating, and the war in Iran. And in my last couple of videos have discussed those. Maybe I'll put links in the description. But in any case, I want to get back to the global heating thing because there's some really weird stuff going on. A few months ago, I started ranting and raging about how I was really worried what was happening with the North Polar Vortex. That is the circulatory air pattern at the very topmost layer of the atmosphere, very near space itself. And it sits like a halo right over the North Pole, and it rotates. It's a very high speed wind, full of cold air, and it basically drives weather patterns in the northern hemisphere. The polar vortex, because of its regular systematic rotation, creates another layer of rotation further down in the atmosphere. So when I'm doing this and this, I'm not doing latitude like from the equator to the North Pole. I'm doing layers in the atmosphere. Okay, so the polar vortex is at the top of the atmosphere, and it influences rotational patterns lower in the layers of the atmosphere, closer to the surface. And one of the major layers of the atmosphere that we recognized, about 70 years ago, we now refer to as the jet stream, because it was discovered in the jet age, the age of jets, after the Second World War. So when we started flying jets, we started flying at high altitudes because that's where the best flying is. We discovered really very strong, highly organized wind patterns, and we named them the jet stream. So 70 years later, we understand that the origin of the jet stream has something to do with the rotation of the polar vortex. So the polar vortex is very important to determining whether we have a jet stream or we don't, how well it's shaped, how strong the winds are. And starting about 20 years ago, climate scientists began to recognize that the jet stream was behaving strangely. They hadn't been studying the polar vortex much because it's, well, for one thing, it's very remote. And being that remote, that high up in the atmosphere, there was kind of an intuitive sense that it didn't matter much. Well, it turns out it matters a lot. So they've been studying it, and it turns out it's kind of a key driver to what's happening with my microphone. It's a key driver to what's happening with the jet stream and with the weather patterns in general. So before I get too much further into that, if you like this kind of content, kind of honest discussions of honest things, important things, subscribe to the channel and drop a like so this information can find a bigger audience out there in the algorithm land. So also, I want to pitch my book. It was 100 Days, an End of Civilization novel. It's based on a combination of what's happening in the Middle East right now, basically wars for oil and also climate change. So again, these two topics are actually really joined at the hip because it's our consumption of fossil fuels that drives changes in the climate, basically in the Earth dynamic system. So it was a fun book to write. I'm pretty happy with how it came out. If you're interested in how these problems overlap and how people deal with them, well, it's 100 Days of People Coping. So you might want to check it out. Available at Amazon. And there is a link in the description. Go help yourself. Now, let's bring this in. This is current data. This is the polar vortex. Let me give you some context here. I'm going to reposition the North Pole directly in the center. So we are looking down on the exact top of the Earth. The North Pole is, I think, right about there. Okay. Now, in the best in the best world, the polar vortex, and this is positioned, just so you know, this view of the atmosphere is positioned at the top of the atmosphere. We're looking at the top of the planet, North Pole being defined as the top of the planet. We're looking down on the top of the planet, but we're also looking at the highest slice of the atmosphere. This is the stratosphere, or close to it. The polar vortex, when properly formed, will be right about here. That is a very good color, but you kind of see what I'm doing here, okay? It's right about here. Right about there. And I could have done that a little better. Let's do it this way. It's right about here. It's centered over the North Pole, and that's about the size that it is. It's not doing that now. Oh, and it hasn't done what it's supposed to do or expected to do certainly for 3 or 4 months. And it really hasn't been healthy for a decade or more. We kind of discovered the importance of the polar vortex in determining Earth system dynamics at about the same time it started to fall apart. So that's not good. It's difficult to study a system that is actively vanishing. It's like studying a species that's going extinct. Okay, you're going to study the species before it goes extinct. You have this big race. Study the last of the species before they go extinct. And then they go extinct. And it's like, well, what was that all about? Why do we care? You couldn't save it. You didn't save it. It went extinct. Now you have all this data on something that's going extinct. With the polar vortex, we're studying something that's probably going extinct. And that's been my concern for a while now. Now, I'm going to show you what's happening here. This is the current strongest gyre of the polar vortex. It's nowhere near the North Pole. It's not very big. It's not very round, and it's nowhere near the North Pole. There is a subgyre that's very weak, very strangely shaped, that is centered over the North Pole. And then there's another subgyre that's rotating in the opposite direction that's way down here, focused over Canada. So that's your polar vortex. That's the state of things, folks. And this is, I don't hear anybody talking about this. I don't think anybody pays that much attention. Or if they are, they're like me. They're like, what does this mean? What has happened? And I'll tell you what I think is happening. I think it's like studying a species that's going extinct. I think we're studying something that's disappearing. Now, maybe it'll disappear and it'll come back and it'll disappear again. But when you see something like this badly degraded, you have to start thinking about the prospect of it just going away. Going away. Now, how did I preface this discussion? I said, the polar vortex, which is at the top of the atmosphere. So now let's use the tools we have here to descend in the layers of the atmosphere. This is the topmost view. I will bring up my menu, and I will go to the next level down. Okay, this is a little deeper. Now there's 2 gyres, and really almost 3, 2 inside of one, big one. And you can see that they're geared together. They're actually rotating in the same direction. Neither one is focused over the North Pole. And that is in contrast to what's going even higher up. So there is massive disruptions taking place as you descend in the atmosphere. About the point where you come to the jet stream, this is what you get. This is the monstrosity. This is driving your weather. This, and further down in the atmosphere, this is what's driving your weather. And you'll see there's twists, there's turns, there's dips, there's ridges and troughs. Cold air is being allowed to fall south, and warm air is being allowed to ascend north. And there was a point earlier in the year when the state of Alaska, which is at the Arctic Circle, the state of Alaska was actually warmer than the state of Florida. And this is why. It was this sort of thing and this sort of thing that caused the state of Florida to be getting air that was colder than was being delivered to the state of Alaska. Alaska was getting rain when they should be getting snow. They had snow and rain at the same time. We call that weather whiplash. It's been happening all over the United States all year, since the fall, since really November. Weather whiplash. Hottest Christmas on record in the lower 48 states, things like that. This is just wild. It's just wild. and people are noticing that it's wild and trying to make up excuses and trying to ignore it. We go a little further down in the atmosphere, the high winds disappear, but you still have various patterns. Like there's a pattern here. I'm going to point to this. I'm going to use my drawing tool. I'm going to point to a pattern here. So first of all, let me give you some orientation. This is the United States, the lower 48, Great Lakes. Okay, here's the UK over here in Ireland, UK and Ireland. This is Japan over here. So again, right, we're looking at the top of the planet, and the U.S. representing North America, the UK and Europe, and Japan over here in the east, and so there's this interesting flow of air right here. You see, this is coming up this way. This is driving something that's really interesting that's happening. I'm going to have to go to the view of the ocean, and I'm going to go to sea surface temperatures. Remember, the North Pole is right here in the center. See this little green line, a green circle? That's where I clicked. That's the North Pole. I just drew a current of air that was blowing like this up in towards the North Pole. Now this is picking up down here. This is fairly warm air. This is in fact, we're having ocean heat waves down here south of Greenland. We're having ocean heat waves. I could bring in the ocean temperatures. I won't do it right now. So this air pattern that's coming in, hitting these warm waters, and then blowing up in here is carrying both warm surface waters to the North Pole. Warm surface waters are being transported to the North Pole, and warm air is being transported to the North Pole. And not too surprisingly, there's a lot of missing sea ice in here. Now, the sea ice doesn't always extend all the way down to Iceland or even, Norway. But there is a lot of ice missing right now. There is we may even have a record amount of ice being missing right now. I could even bring that up. Let me do that quickly. This is a record of sea ice extent. Let's pull this in. Okay, so here's 2026. It's the blue line right here. There's a blue line right here. Okay, this is sea ice in 2026, and this is the average. This gray line is the average. So this is where you would expect it to be. This is how much ice you would expect to be in the vicinity of the North Pole. The actual amount of ice is down here. Now, that's not zero. I mean, zero is at the bottom of the chart, right? So it's not zero, but it's definitely reduced from where it was. And it's also reduced from previous years. Okay, not 2025. 2025 was one of our record hot years. And not too surprisingly, sea ice suffered. Let's look at 2024. Okay, 2024 was higher than both 2025 and 2026. So that's the trend. 2023 was also higher. 2022, we're going backwards in time now, right? So in the recent last few years, the sea ice at the beginning of March, which is what this is, they were all higher than this. So we're going into 2026, the 2026 melt season, because that's what you're going to see here. What happens is that we're still building ice up until about March, and then sometime in around the 1st of April, we start to melt ice, okay? Because now we have summer in the northern hemisphere, and the ice melt proceeds fairly steeply, and then it begins to increase again, and then it picks up over here on the left. So this chart it just goes up. It's sinusoidal. It goes up and down and up and down and up and down every year. However, right now, let me turn off some of these other years. We have 2025 and 2026, we have what is essentially record low sea ice extent. The lowest sea ice extent we've ever had was actually not in the winter. It was down here in the summer of 2012. That's a long time ago. The summer of 2012, we had the lowest extent of sea ice. Still not zero. A little bit above 3 million cubic square kilometers. But getting close to zero. Getting close to zero, folks, compared to, where it's supposed to be. This is the average, and we were at half of the average. Now, that was 2012. It was a record year, record low year. If we want to look at, well, we don't have data for 2026 yet because we haven't had our summer in 2026, but we do have 2025, and as you can see, it was also very low. So 2025 made a shot at the record, and I believe that was the closest one to hitting the 2012 record. What happened in 2012? 2012 was a normal year in every other extent, and you'll see the dotted line. It's close to the average everywhere except in the den of summer. And my recollection is that they had really strange winds that pushed the sea ice out of the North Polar region. Just really high winds that pushed it out. Now, but that is kind of similar to what we're starting to have here. We're having strange winds that are going to blow the sea ice around, melt the sea ice, and we have these sea surface temperatures. And once again, where the seawater goes is dependent upon where the winds are blowing. So it's really important to know what's happening with the winds. And right now, the winds are about the strangest they've ever been. We've had several months now of really weird winds. This is what the jet stream is doing, and this is what the polar vortex is doing. So we have the potential to have some really, really odd, very strange, at least in memory, human memory, things going on. And the ocean temperatures right about here, not too far from the North Pole, this water is not cold. This is off of Norway. This water is not cold. What is the temperatures here? 8 degrees C. That's 8 degrees above freezing. You can't have ice near Norway. Now, I don't know what normally happens with them, but they can't have ice in Norway right now. And we can go even further north than that. Now we're off of the north coast of Sweden, and we're at almost 5 degrees C. That's 5 degrees above freezing. Let's get right up here in this little pocket. This is Svalbard, the islands of Svalbard, which are normally surrounded by ice. And let's just click in this little pocket right here, and that's 1 degree C above freezing. You can't have ice with these conditions. You can't have ice. Now, if you're wondering, oh, well, this is warm water, but is this normal? No, it isn't. These are the heat anomalies. So an anomaly is you put your toe in the water, you say, that's really cold. Then you turn to the person next to you, who's maybe lived in that region for their entire life, and he says, well, I just tested this water. It feels really cold to me. And the person standing next to you says, well, actually, I've lived here for 45 years, and I can tell you that water is hot. And you'll say, no, it feels cold. But for someone who's lived here for 45 years, that water should be colder. And so now you both know something. You both know that there's something going on with the water, that it is getting hot. It doesn't mean the water is hot. It is hotter than it should be, and that's called an anomaly. An anomaly. You need a lot of time data to determine what's normal. And then from normal, you can calculate whether the conditions right now are anomalously hot, anomalously cold, or back to normal again. So I was clicking off of Norway, and so in this chart, normal is basically dark. It's black. So it's not hot and it's not cold. It's normal. So it's black. So if I had to click over here in the black, it is 0 degrees. I'll go back to Celsius. 0 degrees Celsius anomaly, not temperature. 0 degrees Celsius anomaly. So there is no anomaly. So this water off of Greenland, all this black water off of Greenland, is all normal. And this water off of the north of Russia is only a little bit warm. This water north of Alaska is essentially normal. This water over here in the north of Canada, it is essentially normal. It's coded as black. If you see something coded as blue, like this right here, then it's anomalously cold. It's colder than someone who had lived there for decades would expect. And of course, we're not taking people's opinions. Obviously, this is all done with satellite data. I'm just saying that on the ground, that'd be the discussion you're having. And right here off of Norway, This water is 1.5 degrees C warmer than it should be. And there's a wide swath of water here. You way up into the Svalbard, this is 2.5 degrees C anomalously warm. This is, not only is it not freezing, we can go back to this actual sea surface temperatures. Not only is it not freezing at 4.4 degrees C, if we look at the anomaly, it is 2.5 degrees C above what we would expect. So we would expect it to be much closer to freezing. In the winter, above the Arctic Circle, near the North Pole, of course, you'd expect it to be close to freezing, but it's not. Oh, it's plenty cold. You wouldn't want to be in it, but it's not freezing and there's no ice. And that's what's happening with the sea ice. That's why when I go over here and we look at the sea ice, we see that this, which is the current conditions, this is way below the average, which is way up here. This is a significant departure. In fact, the gray bands are your measure of significance. If something is outside the gray bands, not only is it not average, it is significantly not average. I think there's two gray bands here. There's a dark one and a light one. I think the light one is the interdecile range. So that's the 10% error, and so this is way outside of that, way outside of your widest error bar. So not only is it an anomaly if you're just looking at the temperatures, the historic data says that all these temperatures, and we're getting real close to the North Pole, people, really close to the North Pole, and it's 1.2 degrees C above freezing. The North Pole is supposed to be frozen. That's it. And you would expect it to be. And you'd expect there to be a lot of ice. But we're having water intruding near the North Pole that is nowhere near freezing. I mean, not even close. And so these observations that sea ice is collapsing is part of that. Now, when we are dealing with the jet stream and the polar vortices, plural, okay, because now that applies, the polar vortex drives the behavior of the jet streams. The jet streams drive the behavior of the lower atmosphere. And the lower atmosphere drives the currents in the water and the movement of hot air. So when we're looking at something like this, we're saying, well, this is the top of the atmosphere. This is the polar vortex. It looks ugly. It looks strange. It looks really unhealthy. It looks more unhealthy than I've seen it all year since October. Where is this going, man? I don't even know where this is going. But in any case, it is allowing things like this to happen. Hot water is making its way to the North Pole. Now, sometime during the summertime, the North Pole will be ice-free. Other parts of the poles will also be ice-free. Some of the bays and some of the areas, the Canadian archipelago, will become ice-free. At some point, if there's enough hot water intrusion into the North Pole, we may start having ice-free ocean temperatures continuously, so that this chart, it goes down. I'll get a drawing tool. So this chart, this thing continues to go down, and then it gets steeper and steeper and steeper, and it goes down here and it hits zero. No ice in the northern hemisphere, inside the Arctic Circle, and then it stays zero, and then maybe some of the ice starts to come back, and that's what you kind of expect, right? And then it would come over here on the left side, and it would start over again, right? And what's it going to do over here? Well, maybe it's going to melt even faster. Maybe it goes to zero again. Maybe it takes it longer for it to come back. Okay, what you would expect to have happen eventually, and this is what this is where we end up off the edge of the map, because we don't know what this means. Let's say that this line comes down here, and it goes to zero, and it goes along, and it goes to zero, and it stays at zero. Now we should be building ice, but there's so much hot water in the north that you can't build ice. You can't build ice if the water isn't cold. Technically, it has to be below 0 C, right, or below 32 degrees Fahrenheit. You can't build ice if you have warm water. You just can't do it. And under global heating, under the pressure of global heating, we expect eventually that there'll be so much hot water at the North Pole that this line just continues. You can't build ice. And maybe sometime in the dead of winter, you start to build ice again, okay? And then it comes over here and you build ice for a little while and then it starts to drop again. Maybe not that steep. Maybe it takes it a long time to drop, but then you have zero. And then finally you come over here and it starts to build again, but it only builds a little bit and then it goes to zero again. And pretty soon, once this continues, once this hot water keeps pouring into the north, it keeps pouring into the north and the ice keeps failing to come back. You kind of need ice to make ice. Ice is where ice forms. The edges of ice in the water creates more ice because it's absorbing heat. If you don't have any ice, then you get to a point where, at some point, this drops to zero, and it just stays at or near zero, and that's the end. That's the end of the ice age in the north. At that point, we've had a termination event, and all of the ice in the north is gone. All the ice that was left over from the last interglacial glacial maximum is gone. At that point, then you have to look at this thing, and you have to start looking at Greenland, because at that point Greenland would be the only place that has any ice left on it. Now it's on land, so you can have ice on land, but what's happening right now is far more interesting. What's happening right now, get rid of my tool, go back to my air masses, look at the top of the atmosphere. The reason why the polar vortex looks like this is because of something called sudden stratospheric warming. The polar vortex is in the stratosphere. If we start getting warm air intrusions into the stratosphere, now it's supposed to be cold up there. How does that happen? Convection, warm surface waters intruding into the north, as we are seeing actually happen right now. If we start having warm air injections into the stratosphere, then your polar vortex ends up looking like this. And remember, it's supposed to look like where I'm going to put the North Pole right here, and the polar vortex ought to look like this, something like this, about that size and about that shape. Okay, and I can actually go back. Let's see. Let's get rid of the tool and let's grab the calendar. Let's grab the calendar. Here's the calendar, and I can go back a month. Still the 5th, but now a month in the past. And this is what it looks like. Now, this wasn't healthy either. This is the polar vortex broken into 3 parts. Now, the main part is more or less located over the North Pole, but it's got a weird shape, and it broke down even more than this at some point. But there are 3 zones of rotation. You can see that here, but they are mostly, the big one is located over the north. Now, if I go to today, again, the 5th, but a month further out, this is what we're getting. And you can see this is not the same thing at all. It's just not the same. I don't know where this is going, people. I don't like the looks of it. I do not like the looks of this. Let's go back to January 5th, okay? January 5th. Again, a reasonably healthy polar vortex, but there's this little ring up here at the top, and it's a little bit off center. If we go back yet another, go back to 2025, and let's look at December of 2025. Not healthy. Like I said, this has been going on for months, but still, it's big. It's trying to be centered over the North Pole, which is pretty much in the center of this picture. If we go back to the calendar and we go back another month, so this will be the 5th of November. Remember the 5th of November. The polar vortex is not bad. This is not bad. October. Oh, now it's gone. But this is also the end of summer. It can be really diminished in the summertime again because it's destroyed by sudden stratospheric warming. So when you've had a long summer, and this is now November, the date here is October. This is October 5th. If you're looking at October 5th, then it's the end of summer, and this is what you've got for a polar vortex. If we go to now, this is what we have. This is really strange. And I don't know if this recovers, to be quite honest, because we're going into summer, right? And we know that the polar vortex will stumble and become misshapen and putsy towards the summertime. If it's going into that period looking like this, then once again, we may exit the summer and head into winter with essentially no polar vortex to speak of. And if during this period, now this is getting somewhat speculative, but what I'm trying to do is I'm trying to level set. I'm trying to suggest to people that we're going off the edge of the map here. And we're off the edge of the map. We don't even know where the map is. We're off the edge of the map, and we can't find the map. We're in a series of situations that we don't even know what to do, how to deal with this. If we get to a situation where all of this hot water has made its way into the North Pole, okay, and it's been milling around up here, melting ice, heating the water to depth, so the surface of the water is warm, but also deeper layers of the water are also warm. So now you're storing heat. You're storing heat at the North Pole. And if we've had currents, warm currents coming down past Greenland, and we have warm currents hugging the coast of Russia, and we're melting ice and we're destroying ice, and pretty soon there's no ice in the water. If we have that kind of a year where hot water intrusion dominates the North Polar Sea, then we could get to a situation where we can't have ice. I mean, maybe in the depths of winter, December, January, maybe some ice, a little bit of ice comes back. But essentially, when we're supposed to be up here, well, let me clear this first. Where we're supposed to be at least, where we're supposed to be at least up here somewhere in March, we might end up being down here somewhere in March. And eventually, if the water just keeps getting hotter, and we're having marine heat waves, people, I'll go back and show you that in a second, then there's just so much hot water in this system. And the ring fence of the jet stream is broken down, and now that the prevailing winds can't push that warm water away. Instead, it allows the warm water to infiltrate, as we are currently seeing this kind of thing here, where there is warm water intruding into the polar sea. And so if the ring fence that's formed by the winds of the jet stream is so broken down, then we can't keep these warm waters out. Remember, the waters are driven, at least in part, by winds. Winds will push the water here, and it'll push the water someplace else. Well, if you don't have those prevailing winds, then there's nothing to steer this water. And then the warm water simply intrudes. That's what happens. It forms a lens on the surface, and it intrudes from all sides, and the cold water, because it's colder, sinks and disappears. It just sinks. You don't have to warm the cold water. You don't have to warm it. There doesn't have to be a mixing, there doesn't have to be a mixing process. The warm water simply intrudes and forces the cold water down. Just forces it away. Replaces it. That's it. It's a simple replacement event. You don't have to do anything with the cold water. The cold water simply sinks and vanishes, and the warm water intrudes, forms a new layer at the surface of the North Polar Sea, and then that becomes the water. Yeah, there's still cold water, but now it's below. And so the cold water that's below can't really influence what's happening at the surface. And what's happening at the surface? Ice is forming. That's what's happening at the surface. So if you have warm layers of intruded warm water, and then you have a lot of ice melt, and then the warm water remains, and then winter comes, you're done. And you have no ice at the North Pole. How far are we from that? Well, I don't really know. There is I can show you something here. Let me get rid of the tool. You can color these bands to suit yourself. Is this the one? Show all years. Yes, this is the one. I'll invert the colors. So what is this doing? Now this is weird. I want you to look at this bar chart on the right. I'll get my drawing tool. Way down here at the bottom, this is 1979. And the way I've colored these lines is that the oldest ones are further back in time, and the warmest ones are reddest ones. And they are warmest, by the way. Global heating is a thing. are current. So 2026 and 2025 and 2024 are colored red. Now, if there was no systemic change going on, then the blue and the red and the green lines would all be mixed together. And I can actually show you a picture of that. Let's see. I'm going to go back to sea ice today, and I'm going to go. No, I don't. Maybe I can do it here. Hold on. Oh yeah, here it is. It's right here. Okay, but I'm not going to use it there. I'm going to go down here. I'm going to go to my same chart because I want two of them now. I'm going to go to the same chart, and I'm going to pick Antarctic. You see this? You can decide which one you want. So these are the same years. Okay, 2026 at the top, 1972 at the bottom. They're invisible because I haven't clicked Show All Years, right? So I'm going to click Show All Years, and then I'm going to do Classic Rainbow Jet, and I'm going to invert the colors. Now that's the same setup that I have over here. Rainbow Jet, invert colors. Invert colors means I want the bluest ones at the bottom of the chart and the reddest ones at the top of the chart. But the chart is date, year. Okay, so we're making sure that the oldest dates are colored blue and the newest dates are colored red. And I'm trying to make a point. Over here, it's the same. It's the same gradient. You see, the oldest year, 1979, is blue, and the newest year is 2026. Now I want you to look at this set of lines over here. This is Antarctica, okay? Notice what's missing. Notice what's missing. There's no gradient pattern. The Antarctic experience of sea ice melt hasn't been the same as what is happening in the north. These charts are different, and they're not different because they're not different because I made them different. I made them the same. They're different because they're different. The data is different. It's different. The experience in the north is different than the experience in the south. The reason is because, and the reason is obvious, if you understand something really critical here, then the difference is critical. The Antarctic ice is on land. The Antarctic ice is not affected by sea temperatures, not directly, because it's not in the sea. It's not in the water. It's on the land. What does that tell you? That tells you that where sea ice is on land, there's no real gradient pattern. The newest years are about the same pattern. I can hide all layers. So this is what it should be in the Antarctica. This is the average. And if I just start clicking on some years here, you can see, I mean, some of the red dates are definitely, less ice. But if I go down here, you can have, it's all pretty close together. I'm just clicking on some random dates. It's all pretty close together. So even the ones that are anomalously low, and they're not that much lower. And there's no pattern to it. Not really. You go over here, the pattern is obvious. This is the same chart. It's just that this is the Arctic. The Arctic is susceptible to changes in sea water temperature because the ice in the Arctic, except for what's on Greenland, is in the water. The ice is in the water. And where is all the heat on Earth going? Something like 90% of the heat that's generated by the greenhouse effect actually goes into the water. So when we're looking at this, and we're saying, wow, we have warm water making its way into the North Pole. Yes, that's melting the ice. And when it melts the ice, you get this pattern. Every year, there's less ice. Because the water is warmer every year. Why? Because global heating is directional. Everything is getting hotter all the time. And then it's no surprise if we have all this warm water intruding into the North Pole, it's no surprise then that we start to see sudden stratospheric warming of the stratosphere. And that ends up giving us this association with the polar vortex being disrupted by sudden stratospheric warming from all the hot water making its way to the North Pole. So this pattern, these changes in the polar vortex become permanent. This may be an anomaly now. We maybe have not really seen this kind of thing going on in previous years. But because of this pattern where the water in the Arctic is getting warmer and warmer every year. Every time we come back and we get a new line on here, the water is warmer and warmer every time. That's where the heat is coming from that causes a sudden stratospheric warming in the north, which disrupts the polar vortex in the north. And the disruptions to the polar vortex are absolutely critical. This drives your weather. And if you think you've been having crazy weather in the northern hemisphere this winter, you'd be right. And you wouldn't be the only one who had that thought. Well, lots of people are having that thought. I'm seeing a very different discussion, even from corporate meteorologists for corporate media, your news channels. They're finally starting to talk a different talk. This is the talk. They're beginning to mention this. They didn't used to. I think maybe they didn't understand. But in any case, they certainly didn't understand the science of the Earth system. They didn't understand and they didn't care. Because they're supposed to tell you whether you need an umbrella tomorrow when you go to work or if you're going on vacation. That's their job, is to tell you what the weather's going to be like tomorrow. But they have recently been dealing with the crazy weather. And the weather has been crazy this winter, really unhinged and very dangerous. A lot of the weather we've been having in the U.S. 48 states was lethal, very destructive, very destructive. I've talked about it on here a couple of times. If you're living in the United States, then you've probably seen the weather forecasts. Now we're going into spring, we're going into summer, we'll see what happens. One of my concerns is that this disruption in the north is going to allow heat from the south to intrude. I had this picture up here a second ago. I need to be, yes, sea surface temperatures. This intrusion of hot water into the north, heading for the North Pole, maybe to get rid of all the sea ice for all time at some point. Maybe not this year, maybe not next year, but some year from now, very soon, most likely, there will be enough warm water intrusion into the North Polar Sea to make sea ice formation no longer feasible. At the same time this is happening, we're having marine heat waves. So let me go to sea surface temperature anomalies, but now rather than focusing on the North Pole, I'm going to move the Earth up and we're going to look at some other things. Again, these are anomalies. Everywhere you see orange and red, these are sea surface temperatures that are anomalously hot. Look at what's going on down here off of New Zealand. This is really hot water. This is 4 degrees C above average, above normal, 4 degrees C than what you'd expect. And this right here, this is the Gulf of Mexico. I'm looking at the Gulf of Mexico. This is the Gulf of Mexico off the southern U.S. states. This water is having massive impacts on, this warm water is having massive impacts on weather in the lower 48 states. So this massive water, and there's another one over here. It's a little more subtle, but there's another marine heat wave going off on the west coast. That has been very, very interesting. But this stuff in the Gulf of Mexico, the prevailing winds will carry this moisture like this up into the lower 48 states. And when it's doing that, then this moisture becomes available to form rain, hail, tornadoes. If as often as it becomes combined with dry, cooler air coming down from the north, which is happening with increased frequency because of the damage to the jet stream, caused by the damage to the polar vortex, caused by sudden stratospheric warming. I know, it's a lot to string together. That's why this is complicated. That's why no one talks about this. That's why I'm on here. Okay, that's why I'm doing this. Because of all those things, all of which are driven by global heating, then they're having a ocean heat wave in the Gulf of Mexico that's going to loft unusual amounts of hot, moist air into the lower 48 states. As that meets these cold, dry air coming down from the Arctic Circle because of the jet stream being blown up, you're going to get massive, and they were just warning about it today. There's a massive belt of severe weather going to form right here, and that's no accident. And sometimes the meteorologist, the storm weather person, storm prediction center, they'll tell you, oh yeah, this is happening because we're bringing lots of really warm, really moist air up from the Gulf of Mexico, and there is a collision with cold, dry air coming from up here, and then you get tornadoes. They'll connect the dots. Well, what they won't do, and I don't really expect them to, they're meteorologists, they're not climatologists, right? What I don't expect them to do, but they should do, is they should say, and all of this is driven by global heating, because it is. All of it. 100%. I can easily attribute 100% of this to global heating. We've got a marine heat wave right here off of California, in this region right here, and there have been prevailing winds. They're common enough for the year that come in off of the Pacific Ocean. But because the Pacific Ocean contains so much heat, it picks up a lot of water vapor from evaporation from the heat. And it carries that inland. We've been getting atmospheric rivers that come ashore in California, carrying lots of water. We have a lot of water, a lot of rain, broke the drought, which is not a bad thing. And then, this is supposed to be zooming. Oh, it's not, because I have this tool on. Then, over here, off of California, or inland of California, there's a range of mountains we call the Sierra Nevada Mountains. As all this moisture came in off of the Pacific Ocean, and as it picked up more moisture from this marine heat wave caused by global heating, it hit the Sierra Nevada Mountains, froze, and dropped record snows. All of which are going to melt immediately, because now that we're no longer in winter, there's still a marine heat wave going on out here. And as there's any prevailing winds that come in off the Pacific, it's going to carry heat into the Sierra Nevada Mountains. There's not enough cold to freeze it, so you won't get snow. You'll get rain. Torrential rains on torrential snow is going to be torrential floods. And I've seen that in my lifetime. I have seen a situation where we had a lot of snow in the Sierras, and then the month of May came along, or a couple months out, right? We're March right now. The month of May came along, and a warm storm came in off of the Pacific, and it blew up into the Sierras, and all that snow is sitting there, and then it rained hot water on the snow, and rain is the natural enemy of ice. Snow. Rain is the natural enemy of snow. An inch of rain can melt 10 inches of snow. Just like that, like in an hour. An inch of rain can melt 10 inches of snow in no time at all. So if you get rain on top of snow, then all that moisture comes down at once, and you can get monumental floods. So my expectation for California, as all of this snow, which formed because of so much moisture, all this snow is going to find itself confronting global heating. There'll be torrential rains on the torrential snow, and then it's all going to melt. And we're going to have a disaster in California. That has happened before. In my lifetime, it's going to happen again. And in the meantime, even today, they're talking about a group of severe storms coming in through here. Large hail. They're talking about hail the size of like oranges, tennis balls, and tornadoes. Tornado outbreaks, and some of them could be quite strong. Strong tornado outbreaks. They're all going to be doing live streams on YouTube to follow the progress of these terrible storms, which is a good service, because people, not that you can protect your home, really. You can protect your car from hail damage if you park it someplace ahead of time where the hail won't be able to hit it, like inside the garage or down at the mall in the parking structure. You can move your car and avoid the hail. So if you have a warning, you can actually do that. But there's no protecting yourself from tornadoes. You can't protect your house. You can protect yourself in the event of a tornado. So these live events on YouTube where they're actually studying the formation of these supercells and any resulting tornadoes are really important. They're very important services, and I'm glad that people are doing that. Do we learn anything from these things? No, not generally. There's no discussion of why this is happening. It is happening because of the confluence of two things that are created by global heating. Moist air coming in off the Gulf of Mexico, this marine heat wave is happening because of global heating, along with cold, dry air descending down from the Arctic Circle, which is descending down from the Arctic Circle because of problems with the jet stream. So if I were to go to the jet stream, here's the jet stream, a little higher up in the atmosphere. Okay, so this is what they're talking about. So there's a dip here in the jet stream that allows cold, dry air to come down from the Arctic, right? And it just keeps coming down, and it hits this warm, moist air coming up from the Gulf of Mexico. And you kind of, because of the wind lines here, you can see how this actually happens, the gearing of this. It's really fascinating, actually, but it's also horrifying. And this is why they can predict that they're going to have record tornado outbreaks, record hail size, and record everything else, because this setup is the setup. This is the thing. And these big dips in the jet stream and all these loop-de-doops and all this kind of stuff going on, all this crazy stuff, and of course, what can I say? It doesn't just affect the U.S. Here we are over here, and what are we seeing? We're seeing the jet stream pulling up warm air from down here up into the polar regions and causing the warm ocean currents to be blown into the North Pole. And I was just talking about that a little bit ago. And all of this because the polar vortex is blown up. All of our weather patterns are now blown up. When will they ever be normal? I don't know. This is normal. This is now normal. What you're seeing, this is the normal part. If this is bad, if this normal, here's a better view of the jet stream a little higher up in the atmosphere. If this is a problem, then you have a problem. And I don't know how this ever goes away. I don't know how this ever fixes itself. Maybe for a week at a time it comes back and it's normal, but because of the catastrophic warming of the North Polar region, which is a sea, it's water, because there's a marine heat wave going on, and because of the marine heat wave, there's going to be more and more and more hot water intrusion into the north, and there's going to be more and more and more calamitous situations like what's happening in the Gulf of Mexico, what's happening off the west coast of California, what's happening. Oh, yeah, we have to look at this too. Let's look at El Nino. This is the vestiges of the La Nina phenomenon that we had since, a couple of years ago. And now we have a El Nino intruding, right? So the El Nino phase, which is the hot water phase, we can go back in time. Let's go back in time and look at what this looked like a couple of months ago. It changes slowly. It's not really rapid. Let's go back to January of this year. You see, this is La Nina. This is the cold phase of the ENSO, the El Nino Southern Oscillation. And now we're going into, I'll click on now. Now we're going into the warm phase. You see how it changes? And I don't know, can I figure out when the last El Nino was? I think 2022? I'm going to guess here. No, that's back to La Nina. That's a big one. That's a big La Nina. I don't really know when the last El Nino was. It wasn't very strong, by the way. It was kind of putsy. Actually, I do know because they were blaming the sudden heat wave in 2023 on the El Nino. There it is. So this is 2023. The same month. We're still in March the 4th. So this is still March the 4th, and you'll see this tongue of hot water coming in like this, and this is El Nino conditions. Well, this is kind of this is fine. But that was a putsy El Nino back in 2023. We're already having that. Those conditions have already returned. I just jumped forward from 2023 to 2026. So we're going into another El Nino. What's key to 2023 is 2023 was record hot ocean temperatures. Record hot heat wave in the oceans. 100% of that attributable to global heating. We're now going into that again. In addition to going into that El Nino again, we also have this really catastrophic warming of the North Pole. This is the North Pole. I'll go back with the U.S. at the bottom of the picture. This is the North Pole. There is hot water intrusion that's melting ice, and the heat being injected into the North Pole causes sudden stratospheric warming, which gives you this. You get this kind of a thing going on. This then becomes permanent. And if this becomes permanent, then your ocean heat waves can become permanent as well. And if we ever get to a place where there's no ice at the North Pole, and the North Pole can't form ice anymore, then this situation becomes increasingly permanent. And then what? Then what happens? We're off the map. I don't think anybody understands what happens at that point. If we don't have ice in the north, I don't think we know what happens. There you go. What was his name? Some of you probably know. There's another doomer who 10 years ago was saying that if we ever have a blue ocean event in the north, a blue ocean event means there's no ice. That's a white ocean. If there's no ice, then there's a blue ocean. If we ever get a blue ocean event in the north, then that's going to cause massive crop failures. Well, it never happened, but now we have so much heat in the system, and the polar vortex has been so destroyed that I don't see there's any way we can keep an intrusion of record hot seawater from making its way into the north. Do we get a blue ocean event this year? I don't know. We might. But if we don't this year, then maybe some year later. And if that's the case, then Katie barred the door. We don't know what's going to happen. We just don't know what's going to happen. We've been having crazy weather this year with just this kind of thing going on. But, at least this year, we still had ice in the North Pole. This year, we still had ice. Sea surface temperatures. Yeah, see this ice? The ice is gray. We still have ice in the North Pole in the dead of winter. And, of course, we're leaving the dead of winter now. This is going to start to melt. But what happens if we have a blue ocean event and we can't have ice anymore? And then that's it. I don't know. Nor does anybody else. Oh, what if we get what if we get a catastrophic melting of the sea surface methane clathrates in the North Polar Sea? Oh my God, that sets off the methane bomb. Oh my God, that sets off global heating. Then what happens to temperatures? Do we know? Does anyone have a theory? I know they say that the methane bomb is a myth and it'll never happen, but if we have a blue ocean event and there's all this intrusion of hot water into the North Polar Sea, does that just nuke the methane clathrates and let them all loose into the atmosphere? Oh wow, that's going to be a big deal, folks. We don't even know what that means, but I can tell you it's going to be a big deal. And we're there. We're there. And I started this discussion with talking about the polar vortex. This little green dot is at the North Pole. This is bad, people. But in some ways, it's a symptom. In some ways, what's happening here is a symptom. And what is it a symptom of? Okay. It's a symptom of runaway global heating. Where all this is headed, where all of this global heating is headed, and it starts with this kind of a thing, and then it progresses to the blue ocean event, and then it progresses to the next thing, whatever that is. Well, I guess we're going to find out, right? We're going to find out what's next. Where all of this is headed is hothouse Earth. That's where all this is headed, hothouse Earth. And hothouse Earth is going to leave a mark. That's where the Earth becomes essentially uninhabitable for human purposes. Uninhabitable for human purposes. There are places on the Earth already that are too hot to be really habitable. You can't grow food, people can't go outside, lots of air conditioning. Well, yeah, you can have millions of people living in Saudi Arabia now because of electricity and air conditioning and modern cars with air conditioning in the cars and electricity, generation and distribution and all these modern manufacturing to manufacture all these things. You can have all that. And that can say that, and then a lot of people can live in, say, Saudi Arabia or Egypt or Libya, but if the planet gets hotter, then those technologies won't save you. And if the planet gets hot enough, it may start to impact manufacturing and electricity generation. And so you might have air conditioning, but because it got too hot, you can't have electricity. So you can't run your air conditioning. And now all of a sudden you've got millions of people that were allowed to live in places that are, without technology, uninhabitable. And now the technology under heating starts to fail them. And because they are there still and they didn't have a chance to get out, the failure of the technology that sustains them and keeps them alive, when that technology evaporates, they're still there. What happens to them? Well, they leave. If they have money, they leave. These are climate refugees. They leave. They go out. They go somewhere else. Or if they can't do that, then they die. And at some point, hothouse Earth, along with collapse of technologies and collapse of food chains and collapse of electricity deployments, hothouse Earth leads to mass fatality events. And then those parts of the world become uninhabitable. People can't live there. They have to leave. People can't grow food there. They have to grow food somewhere else. All the rest of the planet has been claimed. So now they're refugees invading, if you will, other parts of the world. And they need clothing and water and shelter and food and medicines and schools and hospitals and the whole thing. And will they be welcomed? No, of course not. Of course they won't be. That's a funny thought. We're going to welcome these climate refugees from the places that people can't live anymore? No. That's not going to happen. Well, that's the setup now, isn't it? That's the setup. That's what we're headed into, hothouse Earth. And there's no way out. There's no way to avoid that. There's no way to swerve away from that. Oh, maybe you could say, here's a group of people who are dependent on technology and electricity and modern vehicles and fossil fuels and all this. So they can't, if they don't have those things, they're going to die. So we can't leave them here. You could say that. You could say we have a big project now. We're going to adapt. We're going to move these people out of these places that are going to become uninhabitable. Oh, and here in the U.S., I have some famous names for you. Phoenix, Arizona. Ever heard of that place? Las Vegas. Ever heard of Las Vegas? Yeah, there you go. There's a famous place that's going to become uninhabitable. And what about Southern California? You ever heard of Los Angeles, San Diego, Long Beach? Yeah, Southern California. That place will become uninhabitable. That's 20 million people. 20 million rich people who live in the U.S. already, who can do whatever they want to do. Get in their car, fill up the tank, put the car in gear, and go to any place they want to go to. And you can't stop them from doing that. They're not refugees from Africa. They're not Syrian. They're not Egyptian. They're not Libyan. They're not Saudis. They're American citizens. And they're living in a part of America that becomes uninhabitable. And when does that happen? I don't know. This summer? Yeah, this summer. Southern California could become uninhabitable. I mean, we're just one infrastructure failure away. And the failure can be water supply. The Colorado River gives them a good part of their water. Well, it's drying up. It could dry up this summer. June. They're predicting June. The Colorado River water will no longer be available to Southern California. That's a lot of their water, folks. So we could have an infrastructure failure in water delivery. Well, we could also have an infrastructure failure in electricity delivery. Running at the edge of what's available, and then you exceed that because, of course, it's hot. Everyone turns on their air conditioning at once. Everybody comes home, turns on their air conditioning. They get off work, they come home, they all turn on their air conditioning, and then they start cooking food, and they turn on the internet, and they turn on their TV, and then boom, all the power goes down. Well, now they got nothing. And it's hot. And they were going to cool their apartment with the air conditioning, and the air conditioning just stopped, and there's no electricity anywhere, and there's nowhere to go, and there's no cooling center set up where they can go and try and stay alive. So it's hot. And if they can get the electrical system working the next day, then maybe they'll be fine until the afternoon, and then it all goes off again because nothing has changed. Because really, the place is uninhabitable by modern humans. It kind of always was, but until you had 20 million people, it was something you could overlook. And now that there's 20 million people, and they have problems with water, and they have problems with electricity, and they're already in a concrete jungle, so they have problems with food, and now what? Once again, we're off the map. Could be as soon as this summer. Could be as soon as June, July, August. And Southern California may find themselves in big trouble. Big trouble. Refugees. Mass fatality events. Now, I'm not hoping for that. I'm just here as an engineer and a scientist, and I'm saying that's the setup. That's the setup we're in. And it doesn't have to happen in Southern California. It might happen in parts of India. It might happen in parts of China. It could happen in parts of the Middle East or south of Europe, the south part of Europe. It could even happen in the UK. It could happen in Canada. Oh, they could have enormous fires that just make the air unbreathable, and people become climate refugees because of fires. That's what we're in for, folks. That's where we're headed now, because of a collapse of the Earth dynamic system. And the evidence for that is found in the North Polar Vortex. The evidence for that is found in the wacky weather, the weather whiplash we've been experiencing all winter. Pretty much everywhere in the Northern Hemisphere. Everywhere. Nobody escaped it, really. Everybody in the Northern Hemisphere has several stories they can tell you about how strange and wild and dangerous it was. Several stories. Well, that's now normal. That's where we're headed. That's what we're going to get. So I think I'll stop there. I have other things to do as usual. Once again, while I'm here, my book is available at Amazon. Discusses how people cope with all this once the wheels come off. The wheels are coming off. So, there you go. I wrote the book because I kind of knew the wheels were coming off, and now the wheels are coming off. So, you can't do anything about the wheels coming off, but you can buy my book. You read the book and prepare yourself mentally for the thoughts you're going to have, and the things you're going to have to deal with when the wheels come off. And of course, you can always come back here and watch my videos, because I go on about this stuff, every day now? Oh, and we have a hot war going on, and that's going to interrupt the oil flow, and that's going to cause problems. Oh boy. This is going to be a wild summer, folks. Going to be a wild summer, and if you want to get my cut on what is happening, the truly events in the Earth system that are going to, shake you up, well then, you better subscribe to the channel. And I come back here pretty often these days, talk about this stuff. And when you have a chance, go buy the book and have a look at the book and start preparing yourself mentally. This is where the work has to happen now, folks, right up here. You can't do anything about global heating. All you can do is prepare yourself. Start preparing yourself. And that's why I wrote the book. I want you to read the book. I want you to start preparing yourself up here for the work ahead. And even if you think you're not able to do the work, then maybe you can be the person who helps other people do the work. Because we need leaders, we need thought leaders, and the thought leaders need to understand the challenge. Elders, people who don't have a lot of personal skills, but they can still be thought leaders. And we're going to need electricians, and we're going to need carpenters, and we're going to need bricklayers, and we're going to need people who can dig a hole. People are going to have to live underground. We're going to have to reconfigure our domiciles to be both above ground and below ground. That's the work. Because you can't survive these heat waves above ground. You can survive them below ground. Even if the electricity fails and your air conditioning stops, if you can go below ground, you'll be okay-ish, because the soil will help to mitigate the heat. I'm rambling now, but that's because this is my world now. This is what I'm dealing with all the time. I'm dealing with this all the time. I'm trying to impart some of this wildness that I have to deal with all the time. This is my world. This is the world I live in. I'm trying to impart some of this. That's why I wrote the book, because I could think it through. And you get more of it from the book than you get from me. That's what I got. I'll be back. And we'll be looking at both the war, the problems with oil, the problems with manufacturing and energy development, and of course, global heating, because funny thing happened. It all came together at the same time. Oh boy. Oh boy. Oh man. Don't die.